What up, calculus students? Unit 8, 2 lessons. First one, these calculus word problems called rates, rate problems. The situation we have always is like stuff's coming in, stuff's going out. How much do we have? Okay, think of a water bottle. It starts at a level. We start pouring water in, at the same time water pours out. Maybe the rate that it's pouring in is changing. Maybe the rate that it's pouring out is changing. Well, then what's going on in the level in between? Are we increasing, decreasing? Do we get a max? Do we get a min? Okay? The important thing to think of when you get into these problems that rates are derivatives. Okay? They're velocities. Rates, derivatives, velocity, how quickly something is changing. Now, we know from last unit, if you take an antiderivative of velocity, you get a position. Oh, if you take an antiderivative of a derivative, you'll get the original function. So if we're going to look at antiderivatives of rates, we'll get totals. But we won't be able to take the antiderivative, but we will be able to find the area. And this is where we are going to break out our friend, v, which is x prime. And we learned from last unit that when x prime is positive or negative, my position's increasing or decreasing. The area from like A to B under x prime tells me how much I'm going to increase, how much I'm going to decrease. This is from last unit. We are going to transition back to f's and f primes, but we're going to take a pit stop along the way with p, where p is considered like an amount or a population, a total. We can look at signs of p prime. It'll tell us if the total amount of something is increasing or decreasing. And then the areas under p prime will tell me how much I'm increasing and decreasing. If you don't have a calculator, if you want to find an area, you have to use an antiderivative. Now, the problem is you don't just have one velocity. You don't just have one rate. You have two things going on at the same time. You have a rate that something's being added. Sometimes it's a capital letter. In the first question, the fish question, the rate that fish enter a lake is modeled by capital E. It is in fish per hour. This is a derivative. E is a derivative. Derivatives are in like stuff per time. You've thought of derivatives of being y's per x's. Well, now they can be like fish per hour. That's like an amount. Y's, think of y's as being totals. X, think about like the independent variable x. Well, now we're in like actual things in the real world. Totals, motion, fish per hour, cubic feet of water per day or per hour, per minute, stuff like that. Stuff per time is a rate of change. It's a velocity, okay? But there's also going to be stuff leaving. Write an expression for the total amount at a given time. The total amount at a given time will equal my initial amount plus the total that has come in minus the total that has gone out. The initial amount, I'll say, is P of 0. To find the total in, I need the area under my rates. The area under derivatives are totals. It's probably what I should say. Like area under derivatives equals change in totals, displacements, like we learned in Unit 7. So I'm going to find the area from 0 to some time. I'm going to put t here. Don't worry about it. It's just like I'm going to find the area from 0 to like 8 of E. And that's going to tell me the total in. The total out would be the area under L. Don't worry about this t here. Like you'll see it more on the next lesson. But it's just like for a specific time, I could change this t and I'd change that one and that one. Okay? This is how I'll find a total. Now, we'll go back to see how that can change. Now, if we are adding, if we are removing, if we are increasing, if we are decreasing, if we have maxes or mins, we need our friend Mr. Derivative sign analysis, P prime sign analysis. Well, what would be an expression for P prime? P prime would be the derivative of this initial amount, this 50, the derivative of 50 is 0. The derivative of these integrals, thinking of an integral as being like, oh, I can use an antiderivative to find the area, okay? I can find the antiderivative to find this area. If I take the derivative of this antiderivative, what do I get? Just what I start out with, E. And this should be like E of t, but whatever. This should be L of t, but whatever. The derivative of this integral would just be L. Now this is confusing because like we're used to putting derivatives like with a tick mark, but it's like there's no tick mark here. It's just E minus L. That's okay. Think of V. V didn't have any tick mark, but we know V was a derivative. Velocity was a derivative. In all of your test questions that you had in Unit 7, you were given a velocity. You knew that that was a derivative. Okay, you need to know that E and L are derivatives, okay? Now, this is what we are going to analyze, E minus L. This is what we are going to graph. Like you would graph velocity, figure out when it's positive or negative. This is what we are going to plug into our calculators. Most of our questions are calculators. I just spit something out there. That's great. Okay? Which actually makes me have another way to find a total. If I know P prime is E minus L, I could say my total amount will equal my initial amount plus the displacement or the area under my derivative. It's almost like we could do things separately. We can either have it as two different integrals, total in minus total out, or know that this is just the change in my total. Okay? One way is probably beneficial in certain situations. And this way is beneficial in other situations, depending on what's going on. Okay? This is more familiar to you from Unit 7. This is familiar because it's like a unknown position equals a known position plus my displacement in between the two. This is what you guys spent so much time on, finding maxes and mins of stuff. This is similar. This is the same as this. This really is the same as this, just separated. Okay, cool. All right, every single question you can use a calculator except for the second question. I'm actually going to do the second, I'll do the second question second, just so we can remember. But most of these questions, and I'm going to do the second question last. It's good practice. It's good practice, but I'll tell you right now, on your test, all these rate problems I'm going to give you a calculator on, just so you're prepared for it. Okay, I'm not even going to read the question, the part A, part B, part C, part D. I'm just going to set it up so I know what's going on based on like what's happening and based on the formulas that we were talking about. I got fish leaving at a rate. This is the rate that it's in. It's a velocity. It's a derivative. Fish are leaving at a rate. This is the rate out. It's a derivative. It's a velocity. Okay? So if I were to set up like my main two equations, and also, what am I told? I don't know how many fish there are at t equals 0. So we're going to assume there are no fish in the lake. Okay? Probably a bad assumption, but they don't give you information about an initial amount, so make sure you like know that, okay, the initial amount is 0. Okay, now here are the two, huge formula that you need to use. My total amount, my population, my position, my initial amount plus total in minus total out, or initial amount plus change in my total. Provided I know that P prime would just be E minus L, rate in minus rate out. This can be used at once or it can be used separately. I will be graphing P prime to see when it's positive or negative, to see when things are increasing or decreasing. I'm going to be using my calculator to handle the rest of the stuff. To do my sign analysis, I'm going to need to find zeros. I look like it's talking about an interval from 0 to 8 overall, but we're talking about 0 to 5. So like, boom, we're all set up, okay? P prime will tell me about P, area of P prime, displacement. How many fish enter the lake over a 5-hour period from midnight? Give the answer to the nearest whole number. Team, there's two things that happen in this. Some people get this right, some people get this wrong, because some people do more than they're expected, okay? If I plugged in 5 and said, my population at time 5 is 0 plus total in from 0 to 5 minus total out from 0 to 5, or 0 to 5 there, this would be wrong. We just want the total in. So this is an example of sometimes having things separate is better than having things together. Be ready to use both, whichever one works best for the problem. This would be the answer to part A. The total in is all we're looking for. It's not total amount. So in your calculator, you're not going to do everything. You are just going to go and math 9 it. 0 to 5 of E. Now, I'm going to show you a couple tricks that Mr. Huffaker actually told me. Okay, 153 fish. Now, here are the tricks. Right off the bat, if you're given rates, two different rates, you can graph. I don't know if I want to show this. I'm not going to show this. Never mind. I'm going to stick to my way. We're good. So 153 fish. I'm not going to. I like his idea, but I'm going to stick with what is simpler. 153 fish. Cool. Part B is completely unrelated to what kind of the overall question is asking. Part B, I'm going to skip and do last. So let's go to part C. From 0 to 8 is when is the greatest number of fish in the lake? Justify your answer. Okay, this is when we need a sign analysis. P prime sign analysis, maxes. Okay, everybody, you need, for part C, to have one of two things. Either a statement saying, here's where my candidates come from, and then a list of all the candidates. Or, if you know for a fact what your answer is going to be, and you justify that that has to be the answer, I don't need to analyze candidates, boom, you win, okay? You all need to practice this, and I will be strict about your justifications moving forward, okay? Let's talk. First, let's do our P prime sign analysis. 20 plus 15 sine pi t over 6. That's E minus, use parentheses, L. Be very careful when typing anything in. This is as much a calculator challenge as it is like the analysis of what you get. Type in things carefully. We're going 0 to 8, and we're going to zoom fit. Okay, this is P prime. It's positive. That's negative. Can't really tell which area is greater for a min, but I have 0 graphed as well, so it's time to find my 0. Boom, 6.203. We're going to label that as A. 6.2035644. That's A. P prime is positive until A and then negative after A. That means P is increasing, then decreasing. If you see that this is the location where you have to have a max, you don't have to do what's considered the candidates test. So here is option 1. To answer part C, option 1, P has a max at T equals A because P prime needs to be written down somewhere, is positive from 0 to A, and then P prime is negative from A to 8. Now, you're probably thinking, Mr. Mester, why the hell do I have to write this down? Oh, I'm not going to write this down. I'm just going to reference this. Well, guys, 1 year, the AP exam test graders came together and they said, everybody's using this. This is great. However, they are losing their ability to write things mathematically and to express like why this must be true. Losing some of their mathematical skills by just using a sign chart. So starting 1 year, they said, we will not accept this. This is not acceptable justification. You can use this for a reference, but it's only for your reference. It's only for your reference, not as justification. Now, that just means you have to translate this. Oh, P prime is positive and negative. P has to have a max here. Boom. There's option 1. Good. Here's your other option. This option always works because no matter what, you will find a max if you test your candidates. Here's option 2. You will say P has a max either when P prime equals 0 or an endpoint. Boom. This is establishing where your candidates come from. You need to then compare your candidates. P of 0 is 0. P of 8 we can find. Now, here's where, instead of having things separated in terms of integrals, which you could, we could go in from 0 to 8. Minus out from 0 to 8. Let's actually do the out from 0 to 8 separately. Subtracting those two numbers, total in minus total out. Instead of doing that, you could realize, plus you're adding 0 to it. Instead of doing that, you can just say, oh, the area under P prime will be the displacement of P. I add it to my initial amount. So if you wanted to, you go second, you can go math 9. You can go 0 to 8 of P prime. I graph P prime in Y1. Alpha, F4, Y1, or you go vars, Y vars, function Y1. Boom, you're going to get that same number, 80.9199. Okay, so that's the total amount. You know, we don't know that it's the total amount. It's assumed total amount if there's no population at the beginning. This is kind of like how much you've added over the course of the time. Okay, cool. Now, if I do this from 0 to A, We still have x stored, that 6-point number. Store that as a. P of a equals 0 plus the integral from 0 to a under p prime. Notice I didn't separate this. You guys had all kind of gotten used to figuring out how much we got from 0 to a and a to 8, and I'll show that as well. But again, you got sloppy in terms of showing your work, so it might be easier to just, stick with displacement 0 to a, 0 to 8, instead of separating it from 0 to a, then a to 8. But I'll show you how to get that too. All right, this should be a max number, 135.014 fish. This is the max. This is bigger than my other candidates, so that's the win. You could have also gone 0. You could go 0 to A, and then you could have done A to 8 of y1. And you could have said P of 8 equals P of A plus the integral from A to 8. This is how much we're decreasing. We decreased 54. So this number plus this number would give you that 80.919. Okay? So that's the area under P prime in this case was a positive 135 and then a negative 54. The overall displacement was 80.919. Add that to 0 because you got nothing to start with. Or you could just say, starting with 135.014, adding this number, and I get that 80.919. You'd say that's the max speed. Cool. So 2 options for maxes and mins. If there's one candidate, boom, you're done. You just express the candidate and you win. Or if you want to always stick with the candidates test, here's your candidates test. Now to the trickier parts, part B and part D. Kind of not a part that you'll see all the time, but we're ready for it. What is the average number of fish that leave the lake per hour? Fish that leave the lake per hour is L of T. I'm trying to find the average L of T. Oh, I remember how to find average in this class. 1 over B minus A, integral from A to B of what we're trying to find the average of. If I didn't have a calculator, I'd have to take the antiderivative of L of T. But I do have a calculator, so I'm just going to type it in. So 1/5, math, 9, 0.25, 4 plus 2 to the 0.1 t squared. So I'm kind of thinking that I do like Mr. Huffaker's way of doing things. It is a little bit quicker. What Mr. Huffaker shows his BC students is you graph E. Okay? You graph L. You graph y1 minus y2. y1 minus y2 is what you want to see. y1 and y2 are what you want to potentially use in the home screen. Watch, here's y1 minus y2, something that we're used to seeing when we graphed E minus L. Cool. E minus L is P prime. But now, as long as we've established it, I don't like it because you're going to use y2, but you're not going to label it. You could have done 1/5, math 9, 0 to 5 of y2 and not have to retype things in, which is fun, but yeah, It's up to you. This is a way to get the answers, maybe without having to type stuff into two different locations. Okay, so that was the average. And then, is the rate of change of the number of fish in the lake increasing or decreasing? The way this is worded messes everybody up. Okay, here's part D. Is the rate of change of the number of fish in the lake increasing or decreasing? Everybody gets this wrong because they say, all right, well, here is the graph of P prime. You can press trace and go to 5, and you say, oh, P prime is positive. Okay, P prime of 5 is positive. That means P has to be increasing. This is the whole P prime P. Cool? But it's asking you, is the rate of change increasing or decreasing? This is not correct. It's asking you, is the rate of change increasing or decreasing? That means you need a second derivative. You need the slope of the first derivative. You need not 17.843, rather the derivative of P prime at 5. And that's negative, which means P prime is decreasing. P double prime is E prime minus L prime. E prime minus L prime is negative at 5. It's negative 10.772. Now, a lot of people ask about like units sometimes. P prime of 5 we found was 17.843. How do we get this? This is E of 5 minus L of 5. This is fish per hour minus fish per hour. This is in fish per hour. This is in a velocity. What would this be? Well, it's an acceleration. It's a second derivative. This is in fish per hour, or fish per hour squared. Second derivative is negative. P prime is decreasing. Tricky how they ask that, okay? But we're ready for anything. And it all comes back to really the keys to this problem is this and this, okay? All right. Let's do this problem. No calculator. Ready? 30 birds in a large birdhouse used for migration at the beginning of the spring. Over the course of 10 days, birds entered the house at a rate of that many birds per day, and they left that many birds today. How many birds left the house over the course of the 10 days? Here are my two formulas that are going to define everything. I have 30 birds. I have the rate in, and I have a rate out. So from 0 to some time, if I find the area under my rate in, I'll get my total in. If I go 0 to some time of my rate out, I'll get my total out. If I wanted to examine when birds are at a max or a min, I would take the derivative of P and do a sign analysis, which is E minus L, entering left, P being the population or the position. Total left the house would be this part, would be the total left. So for part A, I'm just going to go 0 to 10 of L of T. I do not have a calculator. You cannot type this into your calculator, but we can do it to check. You do not plug in 10 and 0. You have to remember, if you want to evaluate an integral, you want to find an area, and you don't have a calculator, you need the antiderivative. You need like super big L. Don't divide by 10. You'll find the average L. Don't do any of that. Yes, you'll have a plus C, but it's going to go away. you get 180 minus 50, which is 130, minus 0. This is like big L of 10 minus big L of 0. This is the displacement of L. Okay, cool. B, what was the total amount of birds in the house at the end of 10 days? Well, I already know how many birds left. Now I just need to include how many birds entered. So that'll be this integral. I can do the work on the side. You need to show it, though. T squared would be the antiderivative of 2t. This is how I'd find big E, super big E. And it's got a plus c, but if I find super big E at 10 and super big E at 0, you see it's got 100 minus 0. So I got 30 plus 100 minus 130. So I get 0. Holy cow. The birds are gone. What a design of this problem. I'm so glad it worked out. I made this problem up. Is the amount of birds in the house increasing or decreasing at t equals 5 days by how much? Okay, now we need our derivative sign analysis. Yay! E minus L. Okay, let's write that down. C, P prime equals E minus L, 2t minus 18 minus t. Yo, guys, you don't have a calculator. So you can't graph this, but you can set it equal to 0 and solve. You get 3t minus 18 equals 0, t equals 6. Fantastic. Here is P prime E minus L. Plugging in something before 6 would be a negative. Plugging in something after 6 would be a positive. That's concerning, guys. Why is that concerning? Because I know my population at time 10 is 0. Which means there's going to be a point in time where there's negative birds. Let's not worry about it. Because I end up at a population of 0, P of 10 is 0, I'm going to have to go into negative bird land pretty quickly. Don't worry about it. Are we increasing or decreasing at t equals 5? You know what? I didn't have to do this whole analysis. I could have just found P prime at 5 because I needed to figure out by how much. Plug in 5 and I get 15 minus 18, which is negative 3. This would be birds per day. Decreasing. P prime is negative. P is decreasing by how many? By 3 birds per day. What was the amount of birds in the house of maximum minimum? Okay, so P is going to be a max or a min when P prime equals 0, that's at t equals 6, or an endpoint. We already know P of 0 is 30. We already know P of 10, that's 0. Let's find P of 6. It's going to be a negative number. 30 plus 0 to 6 of 2t. We'll do the work. Minus 0 to 6 of 18 minus t. We're going to lose too many birds. All right, this is t squared. That's 36. So I get 30 plus 36 minus 0. And this is 18t minus 1/2 t squared. So 18 times 6. 48. 108 minus 36 divided by 2, 18. 108 minus 18, 90. Yep. We have negative, that's 66 minus 90. We have negative 24 birds. Fantastic. All right. Bad question, bad design, but execution's fine. All right, cool. Now, other things that happen. Rates could change. Sometimes we'll be increasing, decreasing. With our rates, sometimes our rates will be constant. Sometimes our rates are going to be used for certain time intervals and not used for other time intervals. We're just going to have to adjust and adapt based on what we have. Here, a rate in is R. That's the rate entered. Our rate out is 0.7. Now, you could use an integral to kind of help you, but you also don't have to. You could actually just kind of figure out like 0.7 people per second over how many seconds. But don't worry about it. Like, what you guys have to do with these problems is do them. If you're just copying this down right now, not smart. We are not going to do many practice problems before your quiz. It's going to be a short quiz because we got a big lesson. So if you're not doing these problems, stop and start, okay? And then watch the video to check your work, or else you're not going to have a great time, especially after a long weekend. Here's my initial amount. Let's write down our equations. Let's make sure we're ready. So this is always a good advice for every single rate problem you do, because it's going to show work that might be helpful for all justification of parts. Making sure you have an expression for your total amount, whether it's separated, you can go 0 to like a question mark. Don't worry about like, it's like from 0 to something of R, or you can just do an integral minus 0 to of 0.7, or you could say P prime. The derivative of this is R minus 0.7, which means you don't have to write this separately. It's helpful to know both. You can just say 20 plus the area under P prime, okay? This is everything I need. I got 2 ways to express my population and a derivative. We might need a second derivative, which would be R prime minus 0. We're ready for that. Part A, how many people enter the line? This would be the part of the total population you would need for part A. So for part A, I'm just going to go 0 to 300 of R. If you'd like to go and do the Mr. Huffaker way, we will go and graph R. We will graph the rate out, and we'll have them subtracted. We don't want to graph both. On our equation, we just want to graph y3 and hide the other ones. But once we have it down in this, we're ready to use them. You know, honestly, I think it's going to be helpful, at least for the rest of the homework, doing this. But it's something I don't know if you're going to remember for like the test. What do you guys think? Is this helpful or is this confusing? Do you understand this? We'll find out. Don't show y1. Don't show y2. Show y1 plus y2 from 0 to 300. Zoom fit. Oh boy. Oh no. Okay, not that bad. 2 sign changes. That's P prime. But understanding, you can use now y1 and y2 separately. You just want the integral of R, that's the integral of y1, math 9, 0 to, how much, 300? Of y1. Don't type y1, don't write y1 down as your justification. You should be using that, like that. You get 270. That's a nice number. 270 people enter the line. From 0 to 300, there's always people in line. How many people are in line at 300? Okay, we need everything, or we need this. Let's do both. Part B. You need to show your work, though. Holy cow, do you need to show your work? Either we could do 20 plus 0 to 300 of R minus 0 to 300 of 7.7. You should be able to figure this out. 0.7 people per minute. People per second. 0.7 people per second over 300 seconds. Watch this, 0.7 people per second over 300 seconds. 210. Oh, you could have also gone 0 to 300 of y2, y2 being 0.7. You would also get 210. Right? Okay? Or, if you want to, p of 300 is equal to 20 plus the integral from 0 to 300 of p prime. As long as you have p prime written down somewhere, this is perfect. Let's show both ways. Math 9, 0 to 300 of r. We already did. 0 to 300 of r was 270. Minus 0 to 300 of 0.7, that's 60, so I'm going to get 80. This is doing it separately. Or we could do math 9, 0 to 300 of y3, which is p prime. Keep track of things. y3 is p prime. It's a lot quicker to do it once you type it in once. Boom, you get that 60. Add this 60 to the 20 because you have your initial amount. This is just the displacement. You get 60. You got to understand what p prime shows. P prime shows how much you're going up and going down. The area under p prime. P prime shows whether you're going up or down. The area under p prime shows how much you're going up or going down. Okay, you could separate this into different intervals if you wanted to. You could separate it out if you wanted to, just like you did with position. A lot of you did that. Hopefully, we're just going to be okay with like doing it all at once. Okay. When is the first time there's no people in line for the escalator? People stop entering the line at 300. All of a sudden, they stop entering the line. There's 60 people left in line. Well, since there's 60 people left in line and 0.7 people per second get out of line, we literally could just take 60 and divide it by 0.7. Now, there's other ways to do this, which are a little bit confusing, but I'll show you. Well, the total out is 0.7. From 300 to some time, we will get 60 out. I'm going to show you how you're going to get the same answer. You do 60 divided by 0.7, and that's 85.714. That is after the 300th minute. So it's like you need to add it to 300 so we know what the time is. Watch how I can get this. 60 people in line need to be removed. Take the antiderivative of 0.7, you get 0.7t. Well, we could figure out, and maybe you say it's 0.7x. You could figure out the change in this, 0.7t minus 0.7 times 300. Watch how I can do these calculations of 60 minus 0.7 times 300. And then divide it by 0.7, and I'm going to get the right answer. What happened? I don't think it worked out, actually. Order of operations. Yeah. 60 minus 0.7 times the 100. I needed parentheses. Divided by 0.7. I'm going to get that 385 number. Why didn't that work? Oh my gosh, because you have to add silly Mr. Messner. Like, 0.7 times 300. And also, I didn't multiply by 300. That's a problem. Add this number to solve the equation, Mr. Messner. 60 plus that number. I'm trying to rush right now. Divide this by 0.7. And we are going to get our 385.714 number. All right, last one, and I got to move locations because there's people coming into my room. Come on in. I'm just going to finish up this question and then change locations. No, don't be sorry. All right, what is the number of people in line of minimum? Okay. Break out our friend Mr. P prime sign analysis. There it is. Unfortunately, there's two sign changes, so we can't just say, I know for a fact it's got to be here. So we're going to keep it as simple as possible, and we might have to do a little bit of work, but we're going to be good. We want a minimum. Okay. P is a min. When P prime, make sure it's written down somewhere. Okay, it's written down somewhere. When P prime equals 0 or an endpoint. Okay. Let's find my candidates. Second calc, intersect, bam, bam, bam. I did not graph y equals 0. You need to graph y equals 0. You could have had E minus L up there, or R minus rate out. Second calc, intersect, bam, bam, bam. Okay, we'll call that B. I'm going to keep this as simple as possible. 166.574. We'll call that B. Let's find the other one. $33.013. Call that A. Okay. Let's store that as A. Cool. P of 0. 30. Right? 30 people in line? 20 people in line. I keep saying it's 30. 20 people in line. P of A. 20 plus integral from 0 to A of P prime. Honestly, I think that's the easiest way to do it. 20 plus math 9, 0 to A of P prime. P prime's Y3. You could split it up into two different ones if you want to. Oh, that's a small number. P of B, you can either use 20 plus 0 to B. If you'd like to, you can use P of A plus the integral from A to B. It's up to you. Here's P of A plus the integral from A to B. $251.563. You could have done 20, the initial amount, plus the integral. Honestly, this is easier. It's less to type in. 20 plus the integral from 0 to B. Let your calculator find all of the displacements, all of the changes in position. Oh, that's a problem. Why did I get a different number? Is that because I didn't add? What the hell? Now I'm concerned. Did I save everything correctly? I'm rushing, and that's the biggest problem. I saved that as A. And I saved this as B, and it's 166. Okay, let's start over. 20 plus math 9, 0 to A of P prime. Okay. If I do this from 0 to B, I should get my amount at B. But I should also get that same number if I go from A to B off of A. So let me try that again. Here is P of A. And then I'm adding integral from A to B of y3. What did I mess up? I don't know what I did. I did something wrong. My bad. All right, good. We get that same number two different ways. And then we also need P of 8 or P of 300, which I already found. So I don't have to show work again. P of 300 is 60. Look at that. So, min P of A. You'll say there's 4. Min of 4 based on candidates test. All right, I gotta pause this video and then I will continue it after my next session. All right, back at it. I gotta go a little bit faster here. Change locations. We did this problem in class, so let me show you how to do it really quickly. Here's our population. Rate in, rate out. Here's our derivative, rate in minus rate out. We could also express our population as an area under the derivative plus our initial amount. I would go into my calculator. In Y1, I'll do my rate in. In Y2, I'm going to do my rate out. This helps us not have to worry about subtracting using parentheses or rate out. You could do that, rate in minus rate out, just in Y1 if you wanted to. But this actually helps us to get answers a little bit quicker. I'm going to hide these. I don't want them. I want to see just the derivative p prime. over the interval, zoom fit. We got everything set up. We got our rate in graphed, we got our rate out graphed in y1 and y2. We have y1 minus y2, which is rate in minus rate out, which is p prime. We got our derivative, p prime graphed. We're ready to find anything that we want. Part A, total in is all I want. Total in over the 8 hours will be this integral. You need to list this. And then what I'm going to do, again, I'm not incorporating r minus d. I just want r, which is the rate in. So in the home screen, math 9, 0 to 8 of y1. And again, if you've like typed it in earlier, you could just use it again. 76.570. This is a number that's familiar. This is in cubic feet. This is an amount, cubic feet. A rate of change of the amount. The derivative, cubic feet per hour. Okay, so this is cubic feet. P prime would be cubic feet per hour. P double prime, which will be r prime minus d prime, which might be needed. Cubic feet per hour squared. Okay? Acceleration. Position, velocity, acceleration. F prime, F double. Is the amount of water in the pipe increasing or decreasing? At times 3, I need my sign analysis. I need P prime of 3. This is that extra thing I showed you, which I never asked you. I said, like, how quickly are we moving left or right? Here, we will use trace, or we will literally type in 3 into our original function, r and d. Like r of 3 minus d of 3 is negative 0.313. Negative 0.313 cubic feet per hour. This is a negative number. P is decreasing. Our population, our position is decreasing. Minimum, again, 2 options for this specific example. You have your sign analysis. I didn't do this on the previous question because I was rushing. But your sign analysis in this case of P prime is negative until A and then positive. You know P is decreasing then increasing. You know for a fact that at T equals A, you have a min. Do they ask you for the amount of water? No. At what time is the amount of water a minimum? Option 1 would be the easiest way to answer this question, which is to just be like, I only have one candidate, this is my answer, and this is why, okay? Let's find that value first, and then let me just write that statement, this first option. Okay, let's store that, 3.271. Let's list that off. Okay, store that. Okay. Option 1. T equals A must be the min because P prime, make sure you have P prime listed. Your first thing you should do on these problems is have this stuff up here. Literally, that's the first thing you should have. That way you know it's listed. Since P prime is negative from 0 to A, and then P prime is positive from A to 8. This is your sign analysis put into notation. It is the exact same thing as what this is showing. You might think this is stupid. I have this, Mr. Messer, that's showing me that P decreases then increasing. This has to be a min. Sorry, they don't accept that. Okay, now let's go to option 2. Option 2 is your candidates test. If you're going to use this option 2, you must have this statement. Your statement is P is a min when P prime equals 0 or an endpoint. You now list your candidates. 0, A, 8. You find them all. Let's go into our home screen to do this. Or, I don't know, maybe you keep it here. A lot of you have been using the integral. P of 0 is 30. You need to list this. P of A is P of 0 plus the integral from 0 to A under P prime. You could have this in two different integrals if you want to. You can go 0 to A of E minus 0 to A of, 0 to A of R minus 0 to A of D. But if this is P prime and this is your velocity, a lot of you have been doing 0 as a lower limit, A as the upper limit, and just use this value like that. Negative 2.035. Like, I don't like that because, like, I don't know how to grab that value. It might be saved as a y, but, like, you'd add that to 30, you get like 28 point something. Anyways, I'm just gonna get out of there. Just go 30 plus integral 0 to A, but of y3. Make sure you're using the correct thing. I can see how this is, some of you are going to mess up on this because you're going to keep using y1, when in reality we're using y3, which is our derivative, which is r minus d. 27.964. Again, could you have gotten this by separating it? 30 plus integral 0 to A of y1. So this will be my total in minus 0 to A of y2. Yes. Okay. You get the same as 0 to A of y3, which is y1 minus y2. Now, for P of 8, do whatever you want. If you like to separate your areas and you found this number is that negative 2 point something something, and then you find this number, well, you do P of 8 is P of A plus the integral from A to 8. Or you don't have to show both. You literally could just be like, whatever, calculator, do the work. I already have 0 in. Why don't I just type that in? I'll show you both ways. Hopefully I'll get it right the first time. So here's P of A plus the integral from A to 8 of y3 dx. This is the same as the initial 30 plus the integral from 0 to 8 of y3. Okay, 48.543. Which one involves more work? Option 2 for this problem for sure. But the previous problem, you couldn't have used option 2 because there's multiple candidates, which means like, yes, you could exclude some candidates, but it's easiest to just list off all 4 and find them versus like writing out extra statements for listing off. Min by candidates test. Part D, pipe can hold 50 cubic feet of water. It might seem confusing, but you're going to see how variables in integrals are okay. Okay, there's 50 feet of water is the total before I overflow. Well, I started with 30. You could either start at 30 or you could start at P of 8 if you wanted to. 48.543, and you can either say I'm adding, and you can either have this as separate integrals as 1, from 0 to some number, my displacement. Or here, you'd be adding from 8 to some number, the area, your displacement, area under your derivative, your displacement. Well, what is that number? There you go. W is where it can be placed. You could have also said 50 equals, and if you're more comfortable having it split up, 0 to W of R, that's going to be my total in, minus 0 to W of D, that's my total out. You could use that, or again, you could use 48.543 and then 8 to W, 8 to W. Okay? Next. All right, let's just start it off. Let's write it out. I'm not even reading A, B, C, D. I just got unprocessed gravel arrives at a gravel processing plant. All right, so this is just like a rate in. It's in tons per hour. Tons per hour, okay? It's a derivative. It's a rate of change. It's a velocity. Here's my initial amount. Here's my rate out. Tons per hour. You can do the math. 100 tons per hour over 8 hours, 800 tons total go out. All right? Or you can use an integral. Integral from 0 to 8 of 100 is 800. Anyways, let's write it down. My population is my initial amount plus my total in. It's good to have it listed off from 0 to time of some rate in minus the total out, 0 to some time of my rate out. My derivative of this is going to be G minus 100. My second derivative is going to be just G prime because the derivative of 100. This will be the rate of change of the rate of change. This will be if my rate is increasing or decreasing. This will be how I'm going to check the signs of P prime to figure out if my total amount of gravel is increasing or decreasing. Cool? So we're ready for all three. We have our initial, we have our first derivative, and we have our second derivative. We may or may not use these, but I like putting them all down just so we're ready for it. Position, velocity, acceleration. F prime, F double prime. We also know that P could be my initial, that's a 500, plus my displacement, that's the area under P prime, where P prime is just G minus 100. It's just, instead of separate integrals, one integral. Ooh, yo! G prime of 5, part A. G prime of 5 right there. Forgot to do the other work. What's the other work? Graph rate in, graph rate out, and then subtract them in Y3. The one thing I worry about is like, are you gonna remember to do this on the test? I'm gonna trust Huffaker. Huffaker says this is how he does it. He's always done it, and the students love it. But yes, if we're just doing rate problems, I could see you're not gonna remember this. Are you gonna remember this when we're not doing rate problems? That's what I worry about. Hide Y1, Y2. 0 to 8. Zoom. Fit. Okay, looks like we're going to have a max. P prime is positive and then negative. Now they want G prime of 8. Yo, it's a second derivative. This is tons. This is tons per hour. This is tons per hour squared. This is great. G prime is tons per hour squared. Now it's not going to be this. Actually, it will be. You could take the derivative of G minus 100, and you're going to get G prime. So I can take the derivative of this second calc dy dx at 5. Negative 24.587. Tons per hour per hour. It's an acceleration. You could have also done this by, let's say you're worried about the whole 100 acting. You could have gone math 8, take the derivative of alpha y1, which is my rate in, at 5. Get that same value. Now, what does this mean? It's a rate of change of the rate. It's a rate of change of the rate gravel enters. Don't try to say more than that, because you'll probably mess it up. But it is a rate of a rate. It's a second derivative, a rate of a rate. So put that down. This is the rate of change of the rate gravel arrives. You could say it is the rate of change of G. You could say G is decreasing at a rate of 24.587 tons per hour squared. These are all different ways to contextualize. Sometimes it's easiest to know it's a rate of change of, a derivative is just a rate of change of what you have. So this is probably the easiest thing to remember. You took a derivative, you found the rate of change of what you took the derivative of. If you want to turn this into words, it's fine. I think you'll get full credit there. Part B. Find the total amount of unprocessed gravel that arrives. Total arrives is just this part of it. You don't have to write anything down explaining. You just need to write your integral. This is of y1, not y3. So math 9, 0 to 8, y1. $825.55. 3 decimal places, please. 551. I like to truncate, so I don't have to think. Is the amount of unprocessed gravel at the plant increasing or decreasing at t equals 5? This is when we go back to P prime. P prime tells us if P is increasing or decreasing. This is when I need this sign analysis, G minus 100. Is the total amount increasing or decreasing? We're not looking at a second derivative. We're just looking at our first derivative, which is G minus 100. We've already written that down. So this is G minus 100. I want to figure out the value at 5. It's negative. You would say, I want to hide this because I need it. P prime of 5 is negative 1.859 cubic tons per hour. P is decreasing because the derivative is negative. Doesn't ask you to explain by how much is it. You could have just said P prime of 5 is negative, P is decreasing. Think of P being like a position, not being worried about it. We're good with that. Probably fine for the max or the min. All right, part D. Time for our options. Yo, P prime is positive until A. $4.923. Let's write down that value. P prime is positive until A. P prime is negative after A. T equals A must be the location of the max. Now, do they ask you for the time or the amount? What is the maximum amount of unprocessed gravel at the plant? Justify your answer. So I need the amount, okay? So Here's option 1. T equals A must be the time of a max because P prime is positive from 0 to A. P prime is negative from A to 8. But now I have to find P of A. It's equal to P of 0, which was 500, plus integral from 0 to A of P prime. Got to store X as A. Got to use Y3 because that's P prime, or use Y1 and Y2, that's fine. Just two separate integrals. $500 plus that value, 635.376. Okay? Or option 2. P has a max when P prime equals 0 or an endpoint. Here we go. P of 0 equals 500. P of A, you showed your work up here. Like / you would repeat this work. P of 8 equals. You could either say it's P of A plus the integral from A to 8, or you can go P of 0 plus the integral from 0 to 8. Let's use P of A plus the integral from A to 8. $525. This is of P prime. 0.551. Let's just do it the other way. P of 0 plus the integral from 0 to 8 of P prime. Okay. So, winner. Max by candidates test. Two more? All right. These last two are very important. You're going to have a free response question on your test. There will be a question on your quiz just like this, where it's going to be changing rates, which means you got to use certain rates for certain intervals. You can't use 0, 125, and 108 at the same time. You would need different P primes for different times. Let me just show you. Let's just start it off. I got a rate that snow is being added. I got rate that snow is being removed. There's no snow on Janet's driveway, so we start with 0. Okay? It's not like the fish problem where it's like kind of like, how many fish do we start with? Do I really know the population of fish, or I'm just told how many are entering, how many leaving? So I'm just finding the change of the fish versus finding the displacement of fish versus like actual amounts of fish. This is like not ambiguous. There's no snow to start the day. The initial amount is 0. This is P of 0 is 0. Okay. The amount of snow on the driveway will be 0 plus the total that is accumulated at a specific time. That's why I'm going to use T here. Don't worry about it. We're going to see it. Of F, we're not supposed to use T twice. Don't worry. We'll see that later. Minus 0 to T of G. Okay. P prime will be F minus G, but we're going to go back into that a little bit more. P double prime will be F prime minus G prime. List these off right away. Understand their units. Cubic feet how much snow there is, cubic feet per hour, rate of change, a velocity, cubic feet per hour squared, acceleration, y's, dy dx, d squared y over dx squared. It's all the same. Okay? Now, p prime is tricky, and p double prime is tricky. For the interval 0 to 9, from 0 to 6, you have f minus 0 because there is no removal of snow over this interval. From 6 to 7, I'm using f minus 125. That's p prime. Now, this is not like the values. This is like what the derivative would be. Because from 6 to 7, g is 125. From 7 to 9, I have f minus 108. Okay? Which means my total amount might be tricky because, like, if I were to say my total amount is my initial plus my displacement, well, p prime is different depending on what the interval is. So I honestly am not going to use this, and I'm going to think about understanding that from 0 to 6, I have 0. From 6 to 7, I have 125. From 7 to 9, I have 108. This is my total out and keeping them as separate intervals. If I'm evaluating increasing or decreasing, we're going to have to look at 3 different graphs on 3 different intervals. Anyways, let's see. Part A. How many cubic feet have accumulated by 6 a.m.? Cubic feet that have accumulated is just going to be the total in. This is my total in, 0 to 6 of y1. Don't put y1, put f. I didn't change my graphs, did I? Nope. Now, I'm going to be like cautious about putting in anything for y2. It's all about like my interval. So let's just start with 7t cos. This is why I like the other method. But yeah, what? We're fine. We're fine. I think you guys will figure this out. Hold off on y2 right now. y2 could be 0 if we're looking from 0 to 6. But then it's going to be 125 from 6 to 7. Then it's going to be 108 from 7 to 9. So just hold off. Let's just go and math 9, 0 to 6 of f. $142.27 cubic feet. Okay. B. Find the rate of change of the volume of snow at 8 a.m. Where is 8 a.m. and what is the rate of change of the volume of snow? Yo, P prime is the rate of change of the volume of snow. At 8 a.m., P prime is F minus 108. P prime at 8 is F of 8 minus 108. Now watch what you could do. You could graph 108 and then look from 7 to 9. So you can fit that. And trace and then calculate 8. Or you could literally just type in 8 into F and then subtract 108 from it. Man, Janet needs to graph. Oh, pause. Hide. Zoom. Fit. This is the rate of change. This is the derivative. Yeah. So P prime is negative, which means Janet is crushing right now. Janet is reducing the amount of snow. P prime of 8 is negative 59.582. This is in cubic feet per hour. That is a first derivative. Rate in minus rate out. That's what it is. That's the answer. That means the total amount of snow is decreasing by that much per hour. Part C, let H represent the total amount of snow in cubic feet that Janet has removed from the driveway. Express H as a piecewise function with domain 0 to 9. Okay, so we're talking about our total out here. Total amount of snow removed. There's multiple ways to do it. You could be like, yo, h of t being a piecewise function equals, here's my pieces, 0 from 0 to, what's it, 6? Yeah, 0 from 0 to 6. An integral from 6 to t of 125 from 6 to 7. This is when she had her cup of coffee and she's like crushing. Then from 7 to 9, it's a little tricky. From 7 to 9, she's already gotten this much snow out, and then she's going to get this much snow out from that time. I can see how this is tricky, and this would be one way. Another way, yes, 0 amount of snow removed total. 125 cubic feet per hour from 6 to 7 hours. You could be like t minus 6. So if you plug in 7, you get 125, which is a total amount from 6 to 7. And then from 7 to 9, you've already moved 125, but then you're going to remove 108 cubic feet per hour for 2 more hours. So you have to like subtract 7 so that when you plug in 7, it's just 125, but when you plug in 8, you get that extra 108. Don't stress about this. Don't see many of these piecewise. Like, define this as piecewise. But 2 different ways. It's either just like using an integral for a total out, area under my rate out. Okay, total out from 7 to 9 is like this much plus more. Don't stress about it, but like maybe you can figure it out. But let's go to D. How many cubic feet are in this driveway at 9 a.m.? Perfect. No snow at the beginning of the day. Sorry, let's show this. P of 9. No snow at the beginning of the day. Bunch of snow added. No snow added. No snow removed from 0 to 6. You can either put this in parentheses or subtract each one. Put these parentheses and add them. Again, you could do the math. 125 cubic feet per hour over 1 hour. This is 125. You can use an integral if you're not comfortable. 108 cubic feet per hour over 2 hours, 216. You could do the math. But it is easier to do this than work with like P prime and its graph and using P prime like we did in the earlier problems. It's easier to keep things separated. So we're not ready to just do like one thing all the time. All right, 0 to 9. Do we continuously add snow, or do we stop at 6 a.m.? From midnight to 9 a.m., snow accumulates. All right, that's important. It might be like, yo, from midnight to 6 a.m., snow accumulates, and then it stops, and then we just start removing. But like snow is still falling, and we're shoveling. It's all about that cup. All right, so this is the total in. And then again, like the total out is literally 125 plus 216. And that's the total amount left. Cubic feet. Or 0 to 9 minus 6 to 7 of 125. And I'll just subtract because I didn't use parentheses. 7 to 9 of 108. And you get the same number. Ooh, I got shot. All right, last problem. This is probably the toughest problem. It was in our notes. I didn't show you this graph. I don't like this graph, but we'll be all right. Water in a storage tank. Water in. Water out. Let's figure out that there are 5,000 gallons in the water in the tank at the beginning. Let's write our formulas. X, V, and A. F, F prime, F double prime. P, P prime, P double prime. P will be my 5,000 gallons to start plus my total in minus my total out. P prime will be my rate in minus my rate out. P prime will be different depending on the interval. From 0 to 3, I would have to graph F minus 250. From 3 to 7, I'm going to have to graph F minus 2000. P double prime will be F prime minus G prime. F prime minus G prime. G prime is going to be 0, so P double prime is just going to be F prime because G is a constant. I'm pretty sure we're not going to be asked about P double prime. This is in cubic feet again. No, gallons. Gallons per hour. This is gallons, total amount, position. This is a velocity. This is gallons per hour. This is our first derivative. This is gallons per hour squared. This is my acceleration. Let's go ahead and at least start with my first interval. Rate in. Rate out, which is 250 from 0 to 3. Now I'm going to show you something. Good. Actually, this is fun. See this graph? Here is my rate in, here's my rate out. Here's my rate in, here's my rate out. Here is rate in minus rate out. This graph right here is the graph of P prime. What do you notice? P prime is negative and then positive until this one point right there. Where do they intersect? 1.617. Oh, 1.617 is where they intersect. That is where P prime equals 0. You can kind of see, if you graph things separately, my rate out is larger than my rate in. when my rate out is larger than my rate in, think about this. If P prime is rate in minus rate out, if rate out is bigger than my rate in, this will be negative. P prime negative, P is decreasing. If my rate in is larger than my rate out, which happens here, if rate in is larger than rate out, P prime would be positive, which means P is increasing. All goes to show, like, all this stuff should make sense, and I hope you're thinking about it. Like, I understand what's going on. You can see this graph, and you should be able to understand how this graph with two separate things equates to this graph of P prime, which is negative until this 0, then positive. Anyways, let's do A. How many gallons of water enter the tank from 0 to 7? We're just talking about that part. 0 to 7 of F. You can go into your home screen. F. How many of you have done that? $8,263.806 gallons, round to the nearest gallon. So 8,264 is the approximate amount. Or B, find the time intervals during which the amount of water in the tank is decreasing. Find a reason for each answer. Okay. P is decreasing when P prime is negative. You can see from this graph or from the other graph, P prime is negative from 0 to 1.167 or 1.617. That is my first interval where we decrease. Now you could look up here and you could say, oh, rate out is bigger than rate in again from 3 until 5.076, and boom, you say it's done. But let's just like do what we also could do, which is change this rate out to 2000, change my interval to be 3 to 7. Don't look at your rates out at the same time. You separate them. So 1.617, negative, positive. This is P prime. P is decreasing then increasing. Then again, I don't want to graph 2000. Since I typed in 2000, I graphed it. Then again, we saw on the graph above, the rate out's bigger than the rate in. That means P prime would be negative. Here, this is P prime again that I'm graphing. I'm graphing the derivative. The derivative is negative until 5.076. They gave me that value up here. And then it's positive. That means P prime is decreasing then increasing. This makes sense. Or that P prime is negative then positive. P is decreasing and increasing. So the other one is 3 to 5.076. Probably should have saved those values, but let's see. Part C. At which time is the water in the tank the greatest? All right. What sucks about this is that, you don't have that many candidates, but you'd have to explain why you remove all the candidates. Let me give you option 1. I'm giving you option 1/2. I'm combining what we've done before. where we explain derivatives and we explain derivatives could equal zero or less. Watch what I'm going to say. P could be a max, not just when the derivative is zero. P could be a max when P prime changes sign from positive to negative, or an endpoint. Now look at what I just did. I did not say P could be a max when the derivative is zero. Because if I said that, we would have this as a candidate and this as a candidate. And holy cow, I don't want to worry about 5 different candidates. But the fact that I said, yo, P could be a max when P prime changes sign from positive to negative or an endpoint, this is no longer a candidate and that is no longer a candidate. The only candidates I have are at 0, at 3, and at 7. Don't have to worry about crazy decimals. I mean, you could even say 1.617 can't be a max because P is decreasing from 0 to 1.617. 5.076 can't be a max because P is decreasing from 3 to 5.076. I bet you they would even accept max can't be at 1.617 and 5.076 because of work in part B. I literally think, now that I'm thinking about this question, that was the original design. Is they're telling you, they ask you for part B so that you can know you don't have to check all of those different points for part C. Anyways, for our candidates, there's only 3. None of them have crazy decimals. P of 0, P of 3, which is easy. I mean, you could keep it separate if it makes you more comfortable. Because we haven't found P of 7 yet. And again, I'm not going to use P of 3. I'm just going to go 0. No, why don't we use P of 3? No. Well, let's do P of 7 as 0 to 7 minus 0 to 3 of G, but also minus 3 to 7 of G. 0 to 3 of 250, and then 3 to 7 of 2000. You could do the math on this. This is 250 gallons per hour over 3 hours, 2,000 gallons per hour over 4 hours. This is 750 gallons. This is 8,000 gallons, or type it in your calculator. Didn't have to store anything, didn't have to do anything crazy. There are other ways to get this answered. You guys have to try these questions. You can't just rely on, oh, I saw Mr. Messner do this, so I know what I'm doing. No way. These questions demand practice. For your test, you will have to show your work. You must have all these integrals down. 4513806. I can add the whatever. $5126.590. why don't we just check? Like, if I got that, could I add to that from 327 F and subtract from that 3 to 7 of 2,000, which will be 8,000. 2,000 gallons per hour over the course of 4 hours. Get that 4513? Yeah. So it's all good. Here's my max at 3. You could have said P is a max at endpoint or T equals 3 based on part B. I'm going to actually talk to Mr. Huffaker about this. Now that I looked at this problem again, it's like, yo, they did that on purpose. They don't want all of your candidates. It's excessive. 5 different points where you'd have to do all these finding zeros of the stuff. Anyways, this is a long video, but I hope you understand it. I hope you did it. This is so important. Guaranteed every single year, there's one rate problem that comes up on the AP test. So what we realize after doing it is it's the same as what we've done. It's literally position, velocity, acceleration. Area under velocity is a change in a total. Areas under rates, totals. All right. Later.